We have an integral with some uncommon symbols in the integrand. Let's talk about what these symbols mean and see if it helps us split apart this definite integral. Okay, so we have three different functions here: the floor function, the ceiling function, and the fractional part function. Now let's look at the definitions and do examples. Now, y'all, we're gonna, just because of the nature of an integral where you have limits, lower and upper limits of integration, this floor function is quite suited for integrable functions because it's based on intervals, you know. So, I mean, it's kind of works out. They're bed partners. So let's take a look here at we have x trapped between two integers I and I plus 1, and y'all, what this means is that I, an integer, is less than or equal to x is less than or equal to, or less than, strictly less than I plus 1. Okay. Now, that's what this means. And so for any x in this interval, these are the definitions of respectively the floor, the ceiling, and the fractional part function. So let's work with concrete examples here, then we'll get to the business here. Like, say if you wanted to do the floor of 5.6, okay, well, that is just equal to 5, because 5.6 is between 5 and 6, right? So this is equal to 5. And again, totally in keeping. Again, notice that 5.6 would be strictly between 5 and 5 plus 1, right? In a similar fashion, the ceiling of 5.6 would be 6, not the decimal, but just 5.6 is between 5 and 6, and so the ceiling goes up to the next integer. Okay, and then finally the fractional part, which is a number between 0 and 1, fractional part of 5.6 of course is going to just be 5.6 minus 5. Now again, these are formal definitions. You can do all these things just in your head by having a feeling for what these functions mean. Okay, but this is equal to, and I'll put for emphasis here, 0.6. Okay, now we'll use these definitions to break apart this integral. Okay, and notice we naturally split. Everything is very straightforward here. When you're between 5 and 6, we've just seen here, the floor and the ceiling are 6, right? And then the fractional part would be x minus 5. We need something we can integrate here, right? So again, this is just straight read-offs from these definitions, and the same right here. Okay, so again, immediately from these definitions, we can split the integral quite naturally into these two definite integrals, okay? Now, so what do we get here, folks? Well, one way to think of this, folks, without having to appeal to the fundamental theorem of calculus and find an antiderivative of x minus 5, is just know that this would be equal to 30, which is 5 times 6. And I'm going to do this kind of in a sort of a lame way, I suppose. What you really have here is just a triangle. And I'll go ahead and try to draw a picture here. This would start at 5, right? And end at 6, all right? And its height here would be 6, 1 on the graph, okay? So I'll go ahead and write that. 6, 1, right? If you just plug into them. Okay, so you have 6, 1 is that point right there. But in any event, excuse me, we have a triangle like this, right? So that means the area is 1/2, right? So right here we actually get 30 over 2. Okay, is equal to 15. Y'all, and I won't draw a picture, but in a similar fashion, you would get plus 42 over 2 right here. 42 over 2. So this is equal to what? 15 plus 21. So this is equal to 36 total. 36 square units. 36 SQ. I'll put just units. Okay. We don't know. We didn't say if it's inches, centimeters, or what. But anyway, that's the answer, folks. And again, there was no need to find the antiderivative, even though it's easy. The antiderivative of x minus 5 is what? X squared over 2 minus 5x. But again, that's a little bit too much work when you have this very clear interpretation of a constant times the area of a triangle. And again, just think about this line right here would be the line x minus 5. Okay, that's y equals x shifted to the right 5 units. Okay, but anyway, I hope that got the job done. I didn't draw the picture for you for obvious reasons. But anyway, I think I did the math right. 30 over 2 is 15. 42 over 2 is 21. 21 and 15 is 36 square units. Thanks for watching.